When you're programming IoT devices, your Wi-Fi connection is paramount. If you're not connected to the internet, you are done. It's still a device, but it's not an IoT device. Most examples still have you using Wi-Fi.status to determine whether or not you're connected to the internet. If you're still using that, you probably sometimes feel like there's got to be a better way, and there is. Espressif themselves has events right at the top of their documentation. It's obviously their preferred way for you to handle your Wi-Fi connection. When you use Wi-Fi status, you either know that you are connected or not connected. When you use events and you are disconnected, you are given one of 56 reasons for why you're disconnected. It's a far better way to check your connection, and also it results in a much faster loop. I'd like to introduce today the Wi-Fi events from the Wi-Fi.h library and get you started. And we're going to focus mostly on logging. Logging because it shows you what it does. The purpose of the events are not to log the status, they are to control your Wi-Fi connection. But let's start by logging, understand how it works, and then we're going to start to refactor our code to get something useful out of it. Everything I do today will be in Platform IO. However, it will absolutely work with Arduino. At the end, I'm going to take the code, put it into Arduino IDE, and show you that it works. For today, I'm going to cover 7 steps, which seems maybe a little ambitious. I'm going to start by setting up Wi-Fi for Diagnostics, and what that means is we're not going to deal with reconnection or blocking loops waiting for connection. We are just going to call Wi-Fi begin and then start logging to see what happens. Then I'm going to put everything into a library, mostly just to get things off your main.cpp, off your sketch.ino. Let's get a clear desktop to work with and move the detail to the back so we can focus on what we need to. For logging status codes, well, we're already logging Wi-Fi status. What I mean is we're going to go to the docs and get the names of those status codes and log those so we get better understanding of what our Wi-Fi status is returning before then introducing events. Events are also in the docs. The syntax for the function is a little different than you're used to seeing perhaps, but we'll get that set up and then we'll go to the docs and pull all of the event codes and log those as well so you can see all the different types of events that it's telling you about. And then after that, we're going to get to the most important part, which is the disconnect reasons. It is a lot easier to understand what's happening with your Wi-Fi when you have these very informative reasons being returned to you when there's a failure to connect. When all that's done, we should actually try to do something interesting with this. Logging is very cool, and actually it'll keep you going for a while, at least it did for me. But after that, let's do something more important. Let's start to get set up for how you're going to actually use these tools to manage your Wi-Fi connection. I'll set the stage for that, but we won't actually complete it. There's a lot you can do here, and it's beyond the scope of this video. But lastly, then I will wrap it up. I'm going to do some admin on the library. I'm going to show you that it works in Arduino, and then I will post it to GitHub. So if you're a Platform IO user, you'll be able to just pull the repo down and click compile after you add your Wi-Fi credentials. Arduino users need to copy the library into their libraries folder, and then they can use it. All right, wish us luck. Let's go. We're going to start off with a single file with a regular Wi-Fi setup. We bring in the Wi-Fi.h, give it some credentials, and then call Wi-Fi begin. Most people start with some sort of blocking code right up front. Often print a period or nothing at all, and then wait until the device is connected, and then log that it's connected. The dots give you some indication for how long it takes you to get connected. Rather than printing the dots, we can also just print the Wi-Fi status. (600,600). This function always returns an integer. I'll switch it to 10 milliseconds instead of 200. You see we get different lengths because it takes a different amount of time to connect each time. I'm going to undo this blocking completely. Let's just attach to Wi-Fi and then log the status in the loop and see what we get. And what you get is a 6 followed by some zeros and then a bunch of 3s. Before we go any further, I want to move everything out into a library to extract the complexity away from the main code. I'm going to create a lib folder, give it a Wi-Fi tools folder, and then I'm going to add the 2 files, Wi-Fi tools.h and .cpp, the header and source files. We now have these 3 files. I'm going to break the editor into 3 columns because things are going to be moving back and forth, and I want to show how that's happening. So you know that in our source file, we're going to define our functions. Then in our header file, we're going to prototype them. Our main code is going to include that header file, and then we can use those functions in the main code. After I prototype a class definition and a constructor function to go with it, I'll define the constructor function, which is basically empty because we're not going to inject any parameters or anything into our Wi-Fi tools. We're just going to make it exist. I'll now create it here in main. Let's create our first function. This will be Wi-Fi tools.begin. We're going to bring in the Wi-Fi begin from main. We'll prototype it in the header, and then drop it back into main as Wi-Fi tools.begin. You notice at this point that there's no more references to the capital Wi-Fi in our main file. We can move Wi-Fi.h over to our library source file. But this creates a problem. In our main file, we're calling serial begin and serial.print. These are Arduino functions. They come from the Arduino.h library. If you use Arduino IDE, this library is imported automatically for you, but in Platform I/O it's not. So to make this code work, we would need to include Arduino.h in the file. The reason this code worked before is because Wi-Fi.h actually pulls in Arduino.h, so it was pulled in for you and didn't matter. When we take it away, we now need it. However, I happen to know that I'm going to need Wi-Fi.h in my header file later on in this video. If I bring it here now, both source files can get access to that library through the Wi-Fi tools.h header, meaning we don't need to put Arduino.h in main. If we look at the Wi-Fi begin in our library, it no longer has access to the credentials. So we need to move them over. I'll grab them from main and move them into the header file. I'll make these private variables of the Wi-Fi tools class. Typically when you make a private variable, you put the underscore to denote that it's private. So I'll adjust the Wi-Fi begin as well. That's our first function. Now let's move in our status logs. I'll create a log status method and bring in that code. Then move over to the header file and prototype it. Then come back to main and bring in Wi-Fi tools.log status. I want to address the location of this Wi-Fi tools instantiation. Whenever you have a library with a header and a source, you might define a class, and then in the source file you're going to have some functions that belong to the class. Let's say we have 6 program files that may depend on this library. Maybe we use begin in main, then we want to use maintain in another file, and we want to use log in another file. To do that, we need to include the library in all of those source files. But you can only have one instance of anything in your program. So if we instantiate in main, we would then need to make an extern declaration in our other files for this to work. But there's a more elegant way to do this. We can actually instantiate in our library source file. Then we can declare extern in the header file. So any file that brings in this header file is given access to that one instantiation of the class, our one Wi-Fi tools. It means that in all the files that use this library, they don't need to declare the variable, they just use it. So per that point, I'm going to move my Wi-Fi tools over to the library. Then I'm going to add the extern to the bottom of the header file, and we're good. It's now going to work in main without a problem. So coming out of our 3 columns, look, we have 3 very clean looking files. It was kind of a lot of work, but we're very well set up to add complexity without getting overwhelmed. On second thought, I am going to move this Wi-Fi tools up here. I compile and get an error because you always have to put a semicolon at the end of your class definition, which I did not do. Okay, we're still in business. We got our 603s. We're in a library. Let's start to bring in some of these tables of data to give us more formative logs. So far we've just been logging those integers. I'm going to go into the docs and get the actual names of those different status codes that we get from Wi-Fi.status. When I come into the Wi-Fi docs, there's two files I always get referred to. I'll click on this generic.h. I don't actually want this file, but if I click on source, down at the bottom, we're going to find Wi-Fi type. This gives us a list of all the statuses that Wi-Fi.status emits. I'm going to paste them into a reference folder for safekeeping, and then I'm going to use them in the code in just a second. I want to point out here, this code 254 appears to be obsolete. It gives an error if we even include it, so I'm just going to take it out. Back in the code, I'm going to get rid of this delay and use a timer feature. Status timer and this interval both don't exist, so I'll have to create them in the header file. I create my status timer as a private variable, and then the log interval is going to be a macro definition of 1 second. Notice that all of these values are actually integers. Even though they call it a WL status, we can actually just declare an integer to grab that value. It'll be fine. The reason I'm creating a variable here is because we're going to use it twice. First, just to print the integer. Next, as a reference in a switch case to actually serial print the name of the status code. I'm going to blow through all of this because obviously it's not really coding, it's just doing formatting. So we compile. And there you see, now we've got some additional color. We've got something to look at with our status codes. I'm going to unplug the router. You can see it disconnects and then goes through several different states before it finally eventually returns to connected. After all this talking, I'm now getting to the meat of the video, events. Actually, in the Wi-Fi docs, one of the first things at the top of the file is events. There's a passing reference here to a function that takes an event and info. I scroll down, you find this link to events example, and they show a function that takes an event and then logs the events. I'm going to try that out right now in our program. We can tell Wi-Fi to, on an event, call me. And then we'll write a function call me. And we'll expect it to take an event that has this data type, Wi-Fi event T. And let's simply print out the event. We compile, and you see right off the bat, we're getting 4 events before we even get 1 second into our program. We go straight into connected. I unplug the router, and you start to see we get new events. Our Wi-Fi status is changing, and then we're eventually connected again. In that same link, there's a reference to event codes. I'm going to copy these into our reference folder as well. Right now, I want to make a second source file in our Wi-Fi tools library. We're going to be listing out these tables. It's going to take a lot of room. I don't want to mess up our main file. So I'm going to move log status over to our new debug file. And I need to explain something about this call me function. You notice it's not part of the Wi-Fi tools class. It's a standalone function. That is a requirement. Wi-Fi.onEvent takes our function and sends it to apparently what is regular C, not C++. Classes are a C++ concept, so the function we send here cannot be part of a class instance. Now moving on from that, I want to make a second standalone function. That's because our call me is our event handler. It's going to do more than just logging. I want that to be a separate function on the next page because there's going to be a lot of text. I'll change call me to just call log event for now. We're going to do more here later. By the way, call me is the wrong name. I think I just picked that because I was trying to soften the concept when we first got here. This is an event handler. We should call it an event handler. Now I'll move over to my Wi-Fi tools debug to write my log event. I'll start with what we had before, which is simply printing the event. Then I'm going to bring in that table we got from our docs. Give me a moment to do some formatting, and I'll print that out. We compile, and there you can see now we're starting to get some really informative logs. I'm going to unplug the router. We'll get a disconnect. Several disconnects actually, but you see the status is changing. Plug it back in. We get connected but don't have the IP address yet. There's the IP address. We're now connected. When you look at this table, there's actually quite a lot we can remove. We're not doing anything with Ethernet, so we can take that out. We're not doing anything with IPv6. We can take that out. We're not doing access points. We're not doing WPS. This is actually all we need to care about, our Wi-Fi station mode. We're now finally up to the most valuable part of the video, the disconnect reasons. When I come back to this events example, you remember there's this function that was given an event. But if you scroll down further, they also reference a function that gets both an event and info. I was trying to figure this stuff out for quite a while. In this Git repo, in Wi-Fi generic.cpp, we find a lot of references to event info. Different values are being generated, but they don't seem to be that interesting. It has a lot to do with SSIDs and other notifications we're not too concerned about. There's more of this in stay.cpp as well. I thought I had nothing until I found this. Wi-Fi stay disconnected reason. I kept going through, and finally you find at the bottom of this page, disconnect reason name, a function that returns those. Of all the events that we get that also receive info, I think the only thing we really care about is the disconnect. Why were we disconnected? Everything else is fine. We just need to know why we disconnected. I'm going to copy this into our reference folder and use it. By the way, be mindful of this exact term, Wi-Fi stay disconnected. Of the events we have left, disconnected is a special class that we want to dig further into. Our reason can be found at info.wifi-stay-disconnected.reason. So I'm going to serial print this reason as an integer, and I also want to use the switch case to print out what it actually is. Again, give me a moment for some formatting. Our functions so far were only asking for event. We need to refactor them to receive both an event and info. We'll run it again. Remember, I'm focused on the disconnect notifications. I'm going to pull the router out again, and look what we get. We get multiple disconnect notices, but they have different reasons attached to them. We're really starting to get some good data from our Wi-Fi module. What we've done so far has been informative, but I'm not sure it's been important. The purpose of accessing these events is not for logs. We access the logs to try to understand what's happening, but the purpose for accessing these is to control our Wi-Fi connection. Let's dive into how we can start to make that happen. Here in the event handler, let's just comment out log event, and also let's get rid of log status. Let's just focus on our connection state. The only time you're not connected is when you get a disconnected event. And the only time you're connected is when you get a got IP event. So let's use those. In my event handler, I'm going to say When we get a disconnected event, we are not connected. When we get a got IP event, we are connected. Let's create a Boolean to keep track of this value. Is connected is false to begin with. Of course, if we get this event, it remains false. If we get an IP, it now becomes true. I'll add some serial prints to confirm this on the screen. Got to add the breaks as well. This is a switch case. Now back in main, how are we going to use this? It's pretty simple. If we're connected, run the code that requires a connection. Otherwise, up to you. Maybe here we are going to run our reconnection function, whatever that may be. Calling this Boolean is far more efficient than calling Wi-Fi.status. So right now our loops have already gotten a lot quicker, but further, there's no reason to call a reconnection here like you normally do, because the event is occurring back in the library. We can call our reconnect here and just take it out of our main file. We don't need to see that up front. It should be happening in the background anyway. So we compile, we're connected. I unplug the router, we're disconnected, plug it back in, we're connected. This is the fastest way you can access this information. Okay, that's it. You see how the code works? It's time to wrap this up. I'm going to do some last minute admin and then put it into GitHub for your consumption. First thing is, the event handler and log event, they were left as standalone functions. I said they couldn't be part of the instance, but they can be a member of the class. We are going to have some private values in our class that the event handler should have access to, so I'm going to make it a member of the class. I didn't want to combine these two concepts when we were talking earlier. It will be a member of the class, it just won't be on the Wi-Fi tools instance. So how do we do that? By declaring it static. This will make it a member and it will have access to the other private values, but it won't be on the Wi-Fi tools instance. This will satisfy the onEvent function call. I'm going to do the same thing with log event. Let's make it part of the class. This will not be static, so it will be a part of Wi-Fi tools. We don't need the prototype anymore because it was in the header file. We now call Wi-Fi tools.log event instead of just log event. The log status can be turned on and off in main, but the log event cannot, so I want to put some additional plumbing here to make that possible. I'll create a Boolean, event logging enabled, set it to false, and we're not going to log our events unless that Boolean is enabled. We'll write a new function to enable it. Whenever we call log events, that is going to set that Boolean value to true. Fix a typo here. I need to put the underscore because log event is private. Because we're calling the event handler in Wi-Fi tools.begin, and because event handler was a standalone function, I had it defined above Wi-Fi begin, so it had a prototype. But now that it's a member of the class, we don't need the prototype, so we can move this function definition to below Wi-Fi begin, where I think it more naturally belongs. We compile, and we show that we're connected, but there's no logs. We come back and call Wi-Fi tools.log events, and we get the events. I forgot to bring up RSSI. RSSI is not part of events, and I guess that's why, but RSSI is probably the coolest thing you can log when you're trying to diagnose your Wi-Fi because it gives you signal strength. That might be your problem. Your device might be too far. So when I add that, you see we now get this RSSI reading. -30 is very good. -90 is very bad. Let's test drive our new setup. I'm going to unplug the router. We get a disconnect. I'm going to plug it back in. We get connected. What if we take a walk down the hall? Let's see what happens to our RSSI. As soon as the door closes, you see it drop. I walk down the hall to where the trains run. This is Seoul, Korea. And pretty quickly it breaks. So I turn on, return, and right when I get to the door, it reconnects. So there's our new diagnostic tool in action. I put the credentials in the library before to get them off the main page. But now we've got what we might call a library, so obviously having credentials stuck in there is probably not the best idea. I'm going to pull them back out and put them into main, and we're just going to reconfigure Wi-Fi tools begin to accept those credentials and use them. So I update the definition in the header file and also in the source file. These are no longer private variables, so I have to delete the underscores. I also promised you that whatever we did here today was going to work on Arduino, so I want to prove that now. I'll grab the main code and paste it into Arduino IDE. I need to check the folder first to make sure it's set, and it has changed. I use the projects folder for my Arduino projects, so I need to set it there. You see here is our libraries folder where we keep our shared libraries. So I'm going to go ahead and save as Wi-Fi lab. And then I'm going to go to Windows Explorer and find the folder where we just worked on that project. You see there's the main.cpp. I'm going to go to lib, and we've got a Wi-Fi tools folder. That is the container for our library. I'm going to copy it, move to the project folders, and paste it in the libraries folder. We come back to Arduino IDE, compile, and it fires right up. So there you go, it works. Lastly, I'm pushing this to GitHub. The link will be in the description. Please feel free to download this. Let me know if you have any comments on the video presentation or the code. I am just scratching the surface for what I want to talk about with Wi-Fi. I've got 3 more videos on it coming out. So if this is interesting you, please do subscribe. This is going to be coming out every week. After that, I'll get into provisioning, probably MQTT, and keep going from there. If any of you are... Ooh. Somebody just came home? Yes, I'm recording. All right, good enough for now. I'll see you next week.